we are moving on to the trig portion, the trigonometry portion of this unit. So we've talked about conversions between imperial and SI units, and now we're going to look at some right angle measurements, or sorry, right angle triangles, and some measurements that we can do with right angle triangles. You might remember doing some of this work last year with similar triangles. I know Mr. Neufeld took you guys outside and measured shadows over time and used that kind of measurement to determine the height of an object. Maybe we're going to do that same kind of indirect measurement, but we're going to use trigonometry, and we're just going to start off nice and simple just by knowing the parts of a right angle triangle. So if we're going to do trig in grade 10, so all grade 10 trig, right? You guys are in grade 10, we're doing trig, is for right angled triangles. So all of the angles that we're going to be looking at in this unit have to have a right angle in them. They have to have this 90-degree angle, and you'll see we usually mark that, actually we almost always mark that with a little box, right? So we can see that we've got these 90-degree angles in the triangles on this paper. I'm going to ask you guys to draw them in. Normally what happens is you'd be given a triangle with this box in it to show that it's a right angle triangle. If you don't have that little box, that little right angle notation there, then you actually don't know for certain if you're dealing with a right angle triangle. So you wouldn't be able to use any of our trig strategies that we're using. So 99% of the stuff that you're going to be looking at is going to have that indication for you. Okay? So all we need to do in this lesson is figure out what do we call these parts of a triangle. And because we have these 90-degree angles, we know actually the names of one of them. We know that the side opposite the hypotenuse, opposite the right angle, is our hypotenuse. And you know this from Pythagoras, right? We know the hypotenuse is always the longest length in any right angle triangle. It's going to be the longest side length, and that's because 90 degrees is our largest angle that we can have in a right angle triangle. If this angle is 90 degrees, these two guys have to be smaller than 90 degrees, right? Because the sum of the angles in a triangle is 180. So the 90-degree angle is going to be our largest angle, and we always have our longest side length across from our biggest angle. You might not have known that, but I think it makes an awful lot of sense to students. Then that leaves us with two more sides, and our hypotenuse, we should write this down. Our hypotenuse is always across from the 90-degree angle. It's always across from that 90-degree angle. So we always can label our hypotenuse. So let's go down our page and let's label our hypotenuse. Sometimes students mislabel triangles pretty commonly at the beginning, especially when we're doing trig. So if you find that you're mislabeling triangles or you're getting these trig relationships wrong, I encourage you to, just draw a little arrow. Draw a little arrow from your 90-degree angle to the side opposite or across from it, so you can find your hypotenuse. And just that quick little fix of just really identifying which is the hypotenuse is it just makes things a lot simpler, a lot less confusing. And our bottom triangle here, this is our 90-degree angle, so this is our hypotenuse. Okay, it's always across from our 90-degree angle. That leaves us with two other sides. The other sides of our triangle, our right angle triangle, are called our opposite and the adjacent. Now, the hypotenuse is always going to be kind of in that same spot, right? Across from the 90-degree angle. Our opposite and our adjacent, however, are relative to the angle we need or we're talking about. Let's put talking about. It's not very good verb, right? Across from our indicated angle. So I've put some indicated angles into our triangles here on this. Could just be, you know, in this triangle here, this is our indicated angle. Okay, and we often use the Greek letter theta. Okay, so it's right here. It's another note that I have at the top here. So we often use our theta, this Greek letter theta, to represent our unknown angle. You know how we use x, right, when we have an unknown variable? In angles, instead of using x, theta. Okay, so a couple of new things that are kind of fun for this unit. So if this is our indicated angle, relative to that angle, the side across from our indicated angle is known as our opposite. Right? So across from the indicated angle is the opposite. The opposite is the one side that doesn't create the angle. See how this angle here is created by these two lines here? The opposite doesn't create that angle, right? It kind of cuts that angle off. Now, the other side, our final side, that helps make up theta but isn't the hypotenuse, is called the adjacent. Okay, and you might be familiar with the word adjacent, you know, in English. We say adjacent is kind of next to, right? That means next to. So this side is one of the sides that makes up angle theta that isn't the hypotenuse. And so relative to this indicated angle, this side here is the adjacent. Okay, so our hypotenuse is always going to be in the same spot. It's always across from our 90-degree angle, but our opposite and our adjacent can change relative to the angle we're talking about. So if we move to this triangle here in the middle, right, this is our indicated angle. This little scoopy makes this our indicated angle. Relative to this angle, we can call it theta. Relative to this angle, this side here, across from it, is our opposite. And this side here is our adjacent, right? It's the one next to theta, but not the hypotenuse. Right, next to theta, but not the hypotenuse. Okay? And then finally, if we flip our triangle upside down and our hypotenuse is in a totally different place than we normally see it, normally we see it kind of up here, but again, because it's across from that 90-degree angle, right, we want to watch for that. We want to watch for which one is our hypotenuse. Relative to this angle, this side length here must be what? Well, it's the one that's next to our angle, our indicated angle. So this is our adjacent. Okay, and then across from theta, right, kind of as far away from theta as you can get, is our opposite. Okay, so those are the three sides of our right angle triangle, and it's really important that we kind of sort that out because we're going to attach some ratios to these side lengths, and we're going to be able to solve for any part of a right angle triangle that's missing from these ratios. It's really important that we figure out the names of these guys. One more little tidbit of information that I'd like you to kind of be aware of is how we name side length. So if this is triangle ABC, we'll make this one a right angle triangle. It doesn't have to be. It can be for any triangle. We have, we can name these, we can pick an angle and we can say, you know, which one's the opposite, which one's the adjacent, and which one is the hypotenuse. But we can also name these sides kind of relative to their angles. And so if this is angle A here, the side across from angle A is side BC. But we also give that a little a. Okay, so we use lowercase a for side lengths, and we use uppercase letters like A for angle sizes. Right, so we can call this angle theta, right? Or we can also call it angle A. Okay, so, and then this side length, we can call it BC, but we can also call it little a, right? So that means that B, angle B here, which we made to be our right angle triangle, but I get this naming here, you know, with uppercase and lowercase letters does not have to be just for right angle triangles. But across from angle B is lowercase b for our side length, and across from angle C is lowercase c for our side length. Okay, so this just makes it a little bit easier to differentiate what we're solving for. Are we solving for a side length? Then we use a lowercase letter. If we're solving for an angle, we use an uppercase letter, right? As well as theta too. So we've got a couple of different ways that we'll have to take a look at these. All right, so hopefully that makes a lot of sense, and I need you to do some practice because, again, this can be a really straightforward unit, but it's really hinging on your ability to identify these three sides of a right angle triangle.